Here we want to find the linearization of a function. This looks like if you squared both sides there, you would maybe get an ellipsoid. We're doing that at the point -2, 5, and then we want to approximate a function value here. So here's our equation for linearization, or the tangent line, and our x0, y0 right here, and then x and y here. So we need our partial derivatives right here. So let's go ahead and write our f of xy as 146 minus 3x squared minus 5y squared, and then 1/2 power for our square root. So let's go ahead and find those derivatives at the point 2, -5. So fx here, our x derivative, is going to be 1/2 comes down in front, inside stays the same. Decrease our exponent by 1, so that'll now be a -1/2. And then x derivative of the inside, and the only thing that doesn't have an x derivative, 0, is right there, and its derivative will be -6x. So times a -6x. And then similar for the y derivative, still 1/2, 146 minus 3x squared minus 5y squared, -1/2, but then we do a y derivative of the inside, which will differentiate that term, so -10y. And so each of these you can write as a square root in the denominator. So if we wanted to simplify a little bit here, so this would be a 2 goes into 6 3 times, so -3x up on top. Denominator, we'd have square root 146 minus that 3x squared minus 5y squared. And then we want to evaluate this at the point 2, -5, right? -2, +5. So x is -2, that will give us a 6 on top. And then in the denominator here, we will have a square root 146 minus 3 times x squared. So -2 squared is 4 times, sorry about that, times a -3, so minus 12. And then minus 5y squared. And y is 5, squared is 25, so that'll be -125. And that actually just leaves us 9 in the square root on the bottom. Square root of 9 is 3, so this is 6/3, which is 2. And then down in the y derivative here, 2 goes into 10 5 times, so a -5y. And then again in the denominator, same square root that we had here. And then again evaluate at that point -2, +5. So in the numerator, we're going to have a -25, and then in the denominator, we'll have that square root of 9, which is 3, so -25/3. So 2 is our x derivative, -25/3 is our y derivative. So this will be 2 and -25/3. And then we're going to evaluate the actual function here at that point -2, 5. So we're just going to plug in here, and that's going to give square root of 9, which is 3. And then in the parentheses here, x minus our x0, which is the -2, so x plus 2. And then here, y minus y0, so y minus 5. So remember that x and y here are the variables, and we'll leave those until the last final step here of finding that approximate function value. So to finish up, you've got your L of xy here. So to finish up, you want to just find L, plug in -2.1, comma 5.1. So you're just going to plug those in for x here and y here.